Hello class, hope everything is going well with you at home and that you are ready to do science virtually. Before we left for spring break, we were getting ready to start our Unit 3 science section, which was about the Earth, different types of volcanoes, different types of rocks, and how the Earth moves, how the plates on the Earth move. And we're going to continue on with that. We're just going to change tone a little bit. Some of you may be wondering about your vocabulary, your science vocabulary that we were working on before break. Just due to everything changing, if we end up out of school for the rest of the year, then we will put that on hold and not worry about it. If we end up going back to school, we'll just resume where we took off with the vocabulary. But for right now, we are going to just focus on each little piece of content at a time. The first little piece of content that we're going to work on is volcanoes, and that is what we're going to talk about today. Before we understand the three different types of volcanoes that we're going to study, I want you to have a good idea about the way in which a volcano works, where does the lava come from, and what are the things that are going into causing volcanoes to form. So let's go ahead and begin. So here is obviously a picture of our Earth, the globe. This is a real picture taken from outer space, as you can see. You can tell that we have North America there on top. Some of you may be able to spot Florida, kind of under a cloud. And then the main thing that we see is South America on this picture. The outer layer of the Earth is called the crust. This is the layer that human life exists on. This is where our oceans are, trees are. Anything that we see when we look out of our window, that is on top of the Earth's crust, and that is kind of the outer covering. But what is inside of the Earth? What is below the Earth's crust is what we're going to talk about. There are several different layers that are beneath the Earth's crust. You can see the picture there kind of has it split into different sections. Right below the crust, we have the mantle. This is the thickest layer at about 1,800 miles thick. The mantle is made up of rocks that contain different types of minerals. The next layer of the Earth is the outer core. This layer is about 1,500 miles thick. And inside the outer core is where we have liquid magma, which you may be more familiar with lava. Similar concept. That red kind of area is where we have the liquid magma. And then the third one, the last layer of the Earth, is the inner core. And this is a solid ball of metal. It is about 9,000 degrees Fahrenheit. So for example, when it is a really, really hot day in the summer, maybe it gets to like 100 degrees outside, maybe 101, depending on, or 110 degrees if you maybe live out in California or the desert. But 9,000 degrees Fahrenheit is how hot it is in the center of the Earth, in this area that is made up entirely of metal. Lava that comes from volcanoes is actually found at the bottom of the crust and at the top of the mantle. So I put a green arrow there for you to see. It's kind of an area, it's not super far down actually. It's just right below at the bottom of the crust, and at the top of the mantle is where we have the area that the lava actually comes from. So in that red section of the Earth in this picture, that's kind of where the lava is coming from. And now it's going to bounce for us. Okay, here is a diagram of what a volcano looks like on the inside. So obviously we see those like yellow and gold stripes. That's the actual foundation of the mountain. And then right down the middle, we have that red line. And that represents the lava or the magma. The red represents the lava or the magma. The slide says the main vent reaches all the way down into the layers of the Earth. The main vent is kind of like a tube or a straw that brings the magma or the lava to the top of the volcano, which is the crater. So the crater is the actual spot where the lava comes out of. It's kind of flat. It looks kind of like the middle of a donut. There's like a hole there, and that is where the lava erupts from. This magma is under a lot of pressure. And once the pressure becomes too great, the volcano will erupt, causing the lava to explode. This should say explode, not explore, out of the crater. So again, we've got this long tube or straw-like vent that's reaching down into the Earth's crust and into the top layer of the mantle where we have the magma chamber. And this magma chamber is what it sounds like. It is just a huge opening inside the Earth, like a hole inside the Earth that's filled with lava. And then it is being brought to the surface by this vent. Here's another look at the inside of a volcano, this time with more of a realistic drawing. You can see the sides of the mountain with the green and the rocky portions. Still, we see that long tube or straw-like vent that's reaching down into the layers of the crust and the mantle to reach the magma chamber, which is bringing the lava and the magma up to the top of the volcano at the crater. So there are three different types of volcanoes. Well, there are several types of volcanoes. We're going to discuss three of them today. These are the three main ones. We've got shield volcanoes, cinder volcanoes, and composite volcanoes. Those are the ones we're going to focus on. Shield volcanoes. Here's some facts about the shield volcanoes. And I'll just go ahead and say that one of your assignments that I sent home this week was a Venn diagram. There was 3 circles. And you are supposed to get details and put those on in the circles. We're going to discuss that a little later on, but during that assignment, you're totally able to use this YouTube video, and you can find information about the different volcanoes on these slides. So shield volcanoes. The Hawaiian Islands are all examples of this type of volcano. So if you've ever been to Hawaii and you've seen the volcanoes there, those are shield volcanoes. They are long and broad sloping volcanoes made up of layers of thin runny lava. And what that means is they're not super steep. They're kind of gentle. They don't go up super harshly. They're kind of, as they mentioned, sloping. They go down and go up kind of in a more gentle way. They do not often erupt violently. Mostly what would happen would just be a gentle, slow flow of lava. If you look at the pictures on the bottom here, both of those kind of look almost like rivers of lava. And that's what it means. It's not erupting violently out of the earth, out of the crater, to where like lava is going hundreds of feet up in the air. It's more just slowly flowing down, like you see in these pictures. They're often formed over hot spots, and they are the largest volcanoes. So even though they're not maybe super steep, they're sloping, they gradually get higher, they are still the largest volcanoes. Next, we have cinder volcanoes. These are small and steep, and they're made out of volcanic debris that build up around the vent. So you can see these volcanoes look a little bit more like they're covered with like dirt and ash, and that is what is happening. They're often found on or near a larger volcano. They're the smallest and the most common type of the volcanoes, and they do have violent eruptions with fiery displays of lava. So these volcanoes are what you probably are picturing more when you think of a volcano erupting. We talked this year about Pompeii and how it erupted, and when we're talking about the Romans, that would be more like what we're talking about with cinder volcanoes. A violent eruption goes hundreds of feet into the air, spewing lava everywhere. Next, we have composite volcanoes. These also have violent and explosive eruptions. They erupt not only lava, but actually most of the time what ends up coming out is ash, steam, and gas. You can see in the picture on the right, the one that has smoke coming up, that is most often what's actually coming out of these composite volcanoes. Steam, ash, and gases. It doesn't actually have a lot of lava that is coming out. Mount Rainier, Mount Fuji, and Mount St. Helens are all examples of composite volcanoes. Mount Rainier is the volcano on the left, and Mount St. Helens is actually the volcano on the right with the steam and the gas coming out. They are also made up of layers of ash and thick, sticky lava. Okay, we have some videos to watch. So this is a volcano that is erupting in Japan, and it erupted, as it says, in 2019. Okay, now we're going to look at another volcano video. And this is showing similar to what we talked about with like the shield volcanoes. This would be a common sight of what you would see like if you went to Hawaii, where you have just like a flowing gentle kind of stream almost of the lava. It's not erupting violently, it's just kind of coming out of the earth sort of slowly and in a gentle kind of stream-like manner like we talked about. And if you see off to the sides on the left and the right, it's surrounded by black ground. That is actually dried lava, molten rock, that has stopped, and all of this lava and magma that you're seeing flowing, eventually, since it's now out on the Earth's surface, it's going to cool down, and when it cools down, it will look like this whole area of the black kind of ripply ground that we're seeing on either side of the sort of stream of magma. So this is very, very hot. As it mentioned, the Earth's inner core being about 9,000 degrees Fahrenheit. This isn't going to be that hot because it's now, you know, thousands of miles up on Earth's surface, so it's going to be a lot cooler. But that being said, if you were to touch that, it would probably like take off whatever body part that you touched it with, would just dissolve and be gone, slash, you know, you would be very, very, very injured. So I'm going to pause it here, and you can see the, if you look on the bottom middle part of your screen, you can see a road that's going up into the molten rock, the dried magma. And so this is what happens like in Hawaii. I think this maybe past summer or within the last year or so, they had a volcano erupt, and something similar like this happened there. Anywhere that the lava flowed over, eventually that stuff dried and just left mounds and mounds of dried molten rock and destroyed, of course, everything in its path. You can see that with this road here. Okay, we'll stop there. And last video. So these are volcanoes in Hawaii.
Kilauea is the most active of the 5 volcanoes that make up the island of Hawaii, and is one of the most active volcanoes in the world, as it's been continuously erupting since 1983. Filmmaker and volcano specialist Mark Jagrath visited the area in September 2016 during particularly high levels of volcanic activity. Kilauea is undergoing a period of inflation as the magma reservoir swells. Normally, the lava lake is not visible from the official overlook points, but the level has risen so significantly it can now clearly be seen. And is currently at its highest level since May 2015. It remains to be seen whether this rise will lead to a larger eruption. For the first time in 3 years, the lava flow has travelled the 6.5 miles to the Pacific Ocean, where it cools and hardens. Since 1983, around 500 acres of new land have been added to the island by this solidifying lava. The constantly erupting volcano is a big draw for tourism and attracts around 2.6 million visitors a year, both on land and by sea.
Okay, now let's talk about the assignments. This is the assignment that you were given. It was in one of the packets that your parents brought home. This is a Venn diagram, but a triple Venn diagram. We have done Venn diagrams several times this year, and I believe we've even done a triple Venn diagram before, so you should be relatively familiar with it. There are directions there on the bottom left. It says to put your name on your paper. To complete this triple Venn diagram after you watch this lecture, which is what you just did. And then you're going to have at least 3 details for each type of volcano and at least 1 similarity in each as well. So in these 3 circles where I've got the blue arrows coming in, they're currently wiggling. That is where you are going to write details that are specific to each type of volcano. So for example, the shield volcano, you can go back to rewind back to the slide that talked about shield volcanoes, and you can write 3 of those details in the shield volcano section. Same for cinder cone and same for composite cone. Composite cone is a composite volcano. Then after you write those 3 details in each of those sections, you are going to write 1 similarity for each between the 2 that overlap. So for example, the first arrow here, the pink arrow, is pointing to the section between the shield volcano and the cinder volcano. So you're going to come up with 1 thing, just 1, that the shield volcano and the cinder volcano have in common. The next arrow is pointing between cinder and composite. So you're going to come up with 1 similarity between the cinder cone and the composite cone. And then finally, the last arrow, is between the shield and the composite. And you're going to come up with similarities between those 2. 1 similarity between the shield and the composite volcano. Finally, they're going to do a little flip for us. Finally, the purple arrow here in the middle, I want you to come up with 1 thing that all 3 types of volcanoes have in common. Don't make this too complicated on yourself. Just try to think, what is something they all have in common, and write that. Okay, then it says, don't forget to turn in your Venn diagram. And so this is just to reiterate what I've already sent to your parents in email and what I spoke to them in person if I saw them. Have your parents either text me a picture or email me a picture. They can just take a picture with their phone. If you have a phone, if you have an iPad, you can take a picture of it. You can email it to me. You can text it to me. Your parents have my email and my phone number. And if they do have a scanner, some people have scanners, then you are also welcome to scan the assignment to me as well. Just please make sure your name is on it, even though I can figure it out by figuring out your parents' email and what child belongs to them. It would be easier for me if you just put your name on it. Okay, now let's talk about the 3D sphere volcano activity. In your packet, kind of in the same packet that you found the Venn diagram, you're going to find an assignment that has these 3 pages on it. In addition, there was an instruction page, and then there's another section that has these circles with just blank lines. We're going to talk about all of that. Some of you are going to be able to figure out how to do this if you just read the directions that I sent in the packet. But if you prefer to see kind of more step-by-step, I've included that in here. The first thing you're going to do is you're going to take all 3 of these pictures. Step 1, you're going to color each type. You're going to color it neatly. You're going to color it completely. And you're not going to scribble on it. The third step is to cut out the circles where you can see the scissor icon, and you're going to just follow that line and cut around it. And then step 3, you're going to fold the circles down the middle. Before you, even if you cut, you can see on the top of each picture and at the bottom of each picture, there's a little line. You're going to fold it lengthways down the middle that direction. So when you fold it, you're just going to fold right around that line that's at the top and at the bottom for each one of these 3. The next thing you're going to do is you're going to notice in your packet you've got these 3 circles that have just blank lines on them that are at the bottom. You are going to write information about each volcano in complete sentences. Your Venn diagram can help you. You can use that if you would like. You can go rewind back to the slides in this presentation that contain information about each of the volcanoes, but you're going to write in complete sentences under where it says step 4. You're going to make sure you have neat and legible handwriting. You're going to want to use the information that we found earlier in this video that can help you. And if you want to go even farther, if you want to try to find out more information about the volcanoes, if your parents say it's okay, you can go online and you can research more information about them, and you can totally write that on these circles as well. It doesn't just have to be from this presentation. Step 5 and step 6 are just like you did with the other ones with the drawing. You're going to cut out the circles, and then you're going to fold the circles right down the middle, just like you did last time. Here are some examples of some finished products. What you're going to do is you're going to put glue on the back of the circle with the shield volcano picture. Okay, so find the shield volcano picture. You're going to grab it. It's been folded in half, and you're going to put glue on one of the halves. Then you're going to find the shield volcano fact circle where you wrote all of the information, and you're going to glue the 2 halves together. You're going to continue gluing all of the halves together until you have this 3D kind of ornament that you can use to help you remember. Now, what I want you to think about is step 10. It says, make sure that each volcano is next to the circle with information about that volcano. So the green arrows here, if you notice this section that's visible with the first green arrow at the bottom, that is the picture of the composite volcano. The section that's next to it on the right is the composite volcano information section. And so it should make sure that the 2 that go together are stuck together. All right, hopefully that makes sense to you. It shouldn't be composite volcano picture, shield volcano picture, cinder volcano picture, and then all of the information on the other side. They should kind of alternate. And then again, don't forget to turn in this assignment. Obviously, this is not something your parents can scan to me because it's not flat, it's 3D. So just have them send me a picture or email it to me, whatever is easiest for them. I hope that this made sense. This was our first science lesson. If you would like, then if you couldn't hear me very well, if you want me to try to be louder, if you would like me to include more information, then make sure to leave a comment at the bottom of the video and tell me, Mrs. Faber, oh, can you be louder next time? Or could you go slower? Whatever it is, just leave me some feedback or just even say hi. And then if you have any questions, remember that we are doing an online Zoom meeting. I will be there every day, Monday through Friday from 9 to 12. I will send your parents the link for how to get to it. But basically, just so you know, what's going to happen is I'll send your parents a link. They'll click it, and then it'll basically put you on like a a video call with me, like we're FaceTiming. But what's cool about it is that everybody in the class can be on at the same time, or half of you or whoever needs help, you can call in at 9 o'clock if you have a question for me, and then you can get back with your assignments and get working. And then if you have a question at 9:45, you can call back in, click the link again, and you can ask me more questions. Or if it's outside of that time frame, you or your parents can call, email me, or text me, and I will try to answer your questions as quickly as I possibly can. Good luck. I look forward to seeing you on Zoom on Monday this next week.